All right, grade 12 math 30s or MHF for you students. What I noticed that a lot of students have a bit of an issue with, just because there is a lot of traditional mathematics involved, is when we are asked to solve the roots of a rational equation. Remember what a rational equation is when you have a polynomial divided by another polynomial. Okay, so we essentially got two systems of equations that are divided by each other. And so let's say I have an example over here where I want to find the roots of this rational equation here. So it's 8 over x squared minus 16 plus 1 is equal to 1 over x minus 4. Now usually when you see an x squared like we see over here, you know that at one point in time you're going to use a quadratic formula. But that's usually what we're going to do towards the end. So the way I like to approach this is to do it in steps. The first would be, and this is always, if you can, factor the denominator, and this refers to the quadratic, into what we can call into factored form. So if there are any denominators that are not in factored form, we're going to get them into factored form by dividing them. And so in this question here, we could see that there is, and I'll highlight this in yellow, that this one is not in factored form. This one technically could be. So we're going to factor that denominator and get it into factored form. And so here we have the factored form of x squared minus 16. Now remember, since this is a perfect square, you could use the difference of squares, so a minus b squared is going to be a minus b and then a plus b. And so we have the a minus b and a plus b form over here. So this is the first part. We've now converted the x squared minus 16 into a factored form of x minus 4 and x plus. So once we've got all of our denominators into the factored form, we're going to take that factored form as the lowest common multiple here. And so that's this entire portion over here. That's going to be our lowest common multiple. And we're going to multiply the entire equation by the lowest common multiple. So we took the factored form of the denominator, applied it across all the terms inside the equation, and then what we're going to do is in yellow over here, we'll cancel out any like terms. So those would cancel out, and the x minus 4 would cancel out. And that would leave us with the following so far. So we'd go 8 plus, and then that's 1x minus 4 x plus 4, which is equal to 1. And then that would have canceled out. I don't know why I didn't cancel it out over here. That would cancel out. And we would really just be left with, on the right side, just 1 times x plus 4. And remember, in math, we don't need to write the ones, right? But I just did it to be consistent. And so once we've cleaned up our equation here, we canceled all the like terms. Now we're going to solve for x, and we're going to do that by setting this side to 0. What I do is I do all the foiling as well. So we'll gather like terms as much as we can. When I'm solving this here, I'm going to write 8 plus, and then we're going to multiply each of these within the brackets to remove the brackets. And that'll give us x squared plus 4x minus 4x, right? When we go this times this, and then minus 16. And that's going to equal, when we do distributive property over here, that's just going to be x plus 4. And then gathering like terms, we could see that the b terms here cancel, or the middle terms, and we're left with 8 plus x squared minus 16 equals x plus 4. And then finally, I'm going to now move the right side of my equation over here. And plugging in everything, we're going to go, and I'll keep this in red here. We're going to go 8 plus x squared minus x minus 4, because when we bring these to the other side, they switch their signs. Minus 16 is equal to 0. And then that would leave me with x squared minus x minus 12 is equal to 0. And now I can just factor it to get the exact roots. So I multiply the first and last terms, and that'll give me negative 12. I'm going to list the factors that are going to, when I multiply them, they add up, they give a product of negative 12, but when I add them up, they give a sum of negative 1, which is the middle term here. And of course, that would be x minus 4 and x plus 3. And so these are the possible roots, or the exact roots of the equation. And if you wanted to know the exact root, which one it could be here, well, when we go back to the original term, we can see that if x is 4, then you would get a 0 on the denominator, which means that that's not a possible factor. So I'm going to write x equals 4 would give 0, which is not a rational answer. So that means, more specifically, that x would have to equal negative 3. So welcome back again. We're going to do a second example now. We're going to find the roots of this rational expression or equation here, and we're going to follow the same rules that we did with the previous examples. For the first thing that we're going to do is we're going to look at all the denominators here and see if there's any that we can factor down or get them into factored form. These two are already in factored form, or simplified factored form, so what we're going to do is focus in on this one and get it into factored form so that hopefully we'll have a lowest common denominator here, so, or lowest common multiple. So if we factor this out, we're going to end up with x plus 2 and then x plus 3. And it doesn't matter in what order we would have to write this. So remember that when we're factoring, we're looking at which of the two, when we multiply the first and last terms, which numbers, when we multiply them, give us the product of 6, right? 1 times 6 is 6. And then when you add them together, they give us a product of 5 in the middle. So now we can rewrite this as x, and I'll scroll up here, x plus 2 over x plus 2, and then x plus 3, and I'll just extend the line over here. And then that equals to 5, and then x plus 3 here. Okay, so now that we've got our factors here, everything is in factored form, we can now take that factor, like we did in the first one. The factors from the quadratic are going to be our lowest common denominator. So we're going to multiply the entire equation by x plus 2 times x